Hi scientists, welcome to Science Explorers Water Rules. I'm Jellyfish Jill, and in today's lesson, we're going to explore the properties of water. But before we get into the science of water, we need to set up one of our experiments that's going to take a little bit of time to work. So what you need for tonight's first experiment, Water Highway, are 3 cups, 5-ounce size. You need blue and yellow food coloring, 1 full-size paper towel cut in half, and some water. Go ahead, pause your video, and press play when you're ready to start. Let's start building our water highway. So you need 2 cups that are half full with water and 1 empty cup in the middle. On one side, we're going to put a few blue food coloring drops in one of the cups of water. And in the other, we're going to go ahead and put a few drops of the yellow. Next, we're going to go ahead and fold our paper towel in half, and then in half again so that it is in fourths. So we're going to go in half, and then in half again to make fourths. Okay, so now what we're going to do is we're going to dip one end of one paper towel in the blue cup and one end in the empty cup. And you're going to take your other paper towel and you're going to dip one end in the yellow cup and you're going to put the other end in the empty cup. We'll make observations throughout our lesson today. But right now I want you to make a hypothesis. What do you think is going to happen? So water is such a common part of our everyday lives that we don't really think too much about it, but it has very unique properties. So one really amazing fact about water is that it's the only substance that can occur naturally in 3 different forms, which we call the states of matter. So can you name those 3 states of matter? What state of matter is water? We know this is a liquid, right? What other states can water exist in? Well, if I pour this into the freezer, what's going to happen to it? It freezes and it becomes ice. What state of matter is ice? We know ice is a solid, but I can take this same cup of water and I can pour it into a pot on my stove and I can bring it to a boil. And in this case, something else is happening. It's changing states again. It's going to turn into a water vapor, which is a gas. And we know this because we see steam rising from a pot of boiling water on the stove. So let's do a little bit more exploring with the properties of water. So for this experiment, you need a piece of wax paper, a 3.25-ounce cup full of water, and a pipette. Pause the video until you're ready to get started. To explore water, what we're going to do is we're going to put some of the water onto the wax paper and we're going to look at its shape. So we're going to use our pipette. To use a pipette, you put it down into the water, you squeeze the top, which we call the bulb, and it's going to squirt the water up into the pipette, and then you just squeeze the bulb again to let the water out. So go ahead and put a few drops onto your wax paper. Notice they kind of combine to make a bigger drop. And if you had to describe the shape here, this looks like a dome, right? What do you think this dome forms? Well, it's because water molecules are attracted to one another, and we call this the property of cohesion. It means they cling together on the surface, so they form this dome shape on the top. How big can you make your dome on your wax paper? Go ahead and take a few minutes to explore that. So because of cohesion, water molecules actually line up and hold on to each other, forming a layer of skin on the surface of water. So this layer is scientifically referred to as surface tension. And if you've ever seen an insect walking on water, you've seen surface tension in action. So take a look at this picture here. This is an example of an insect that you might see if you're ever at a lake. This is called a water strider. And it looks like they sort of glide across the top of the water. And it's because they're sitting on top of that dome that was formed by cohesion, which we call surface tension. Now I want you to go ahead and put a couple more drops close to your big dome. And I want you to use your pipette to kind of push that pile closer to the other pile. What happens? Did you see that? Here, let me show you again. As I push it closer, once it touches, look, the smaller pile merges with the larger pile. So, what was the science here? We had a small pile of water and a larger pile of water, and they merged together. This is because water molecules are attracted to each other. So water molecules are attracted to other molecules, and cohesion brings them together. But why do you think water molecules are attracted to each other in the first place? Why do they like to stick together? It actually has to do with their chemical composition. So the chemical composition refers to the substances that make up water. What is the composition of water? It's H2O. So the H's stand for hydrogen, and there's two of them, and the O stands for oxygen. So water is composed of two hydrogen atoms and one atom of oxygen. So once they're chemically linked, they form a molecule of water known as H2O. So water is a polar molecule, which means that it has a positive end and it has a negative end. So it's similar to the North Pole and the South Poles of a magnet. We know they're attracted together. So the hydrogen atoms of a water molecule are going to be attracted to the oxygen molecules of another water molecule. Again, we call this joining together cohesion. Activity 3 is called the Water Drop Challenge. For this activity, you need a plate, a penny, the cup of water from our last activity, and your pipette. So the challenge here is for you to see how many drops of water you can fit on this penny. You want to be careful to make sure all of your drops are the same size. Okay, I'm going to stop there because I want you to make your own hypothesis on how many drops you think you're going to fit on this penny. So when the water spills over, that means one too many drops have been added to your penny. Go ahead, pause the video, make your hypothesis, and then test your hypothesis. Okay, how many was it? Compare your actual amount to your hypothesis. Were they close or were they far away? Were you surprised by your results? So mine spilled over on 28 drops, which means 27 drops fit onto my penny. So we know that water molecules are attracted to each other, and this is called cohesion. However, water molecules are also attracted to other materials. So this property that allows water molecules to be attracted to other substances is called adhesion. So due to water's ability to cohere or stick together like this, or adhere and stick to other molecules, this penny was able to hold more water than you might have thought. Now that we understand that two water molecules can be attracted to one another, and we call this cohesion, and water molecules can also be attracted to other substances, which is called adhesion. We're going to do some interesting experiments with water and show off these amazing properties in action. Activity 4 is called floating paperclip. for this one, what you're going to need is a plate. This is going to be your spill catcher in case your water spills over. You need a new souffle cup. You need a paper clip. Then you're also going to use your souffle cup from the previous activity along with your pipette, and you'll need a little bit more water. So go ahead and gather your materials and come back when you're ready. Okay, so the first thing that we're going to do is we are going to fill the souffle cup that's on your plate close to the top. And what we have to do is we want to create a dome shape on top of this. We're going to slowly add some more water with our pipette until the water level is above the rim of the cup. So you're going to slowly add it, keep adding drops, till if you look from the side, you can see that that dome comes right up over the top of your cup. Remember, this dome is called surface tension. The attraction of those water molecules to each other at the surface keeps them from spilling over. So the next thing we're going to do is we're going to take our paper clip and we're going to carefully set it on the edge of the cup. Like that. Then we're going to gently push that paper clip into the middle of the cup. We want to be careful not to actually touch the water with our fingers. So I'm going to use the end of my pipette there. Can you see that it is floating? And look, it traveled right to the other side. I'm going to push it again so you can see it's still on the top. It didn't sink down, which is weird, right? Because we know that a paper clip is more dense than water, so shouldn't that be sinking? It doesn't, it stays on the top. So what's the science here? If the weight of our paper clip is evenly distributed, it is then able to float due to the surface tension of the water. The attraction of water molecules create that thin layer on the surface of the water. And if we look from the side of the cup, we can see that layer of water on the top, that dome shape. So surface tension supports objects that are even denser than water itself, such as this paper clip. Activity 5 is called Scare the Pepper. So for this one, you are going to need the plate and the souffle cup of water from our last activity. You're also going to need 2 packets of pepper, some dish detergent, and your pipette. Go ahead and pause the video until you're ready to get started. Step 1, we need to go ahead and sprinkle the pepper packets into the cup of water. Notice surface tension right now is keeping the pepper on the surface of the water. Next step, we're going to use our pipette to get a little bit of soap into the pipette. And we're going to add a drop of dish soap to the cup with the pepper, and we're going to observe what happens. What do you think is going to happen? Make a hypothesis. Now let's test it. Wow! Did you see that pepper run? It ran from that detergent. So why did that happen? What's the science behind it? Well, the soap broke the surface tension of the water by weakening those hydrogen bonds that hold water molecules tightly together at the surface, and that caused the pepper to disperse to the edges. In activity 6, we're going to demonstrate both adhesion and cohesion. So again, you're going to need a cup of water, and then the only other material that you need is a piece of newspaper print paper. So the first thing that we're going to do is we're going to fold this paper so that it is in an accordion shape. So fold it towards you, make a crease, then you're going to fold it back, make a crease, fold it forward, make a crease, fold it back, make a crease, fold it forward, make a crease. So So see, it ends up being in an accordion shape. Okay, now what we're going to do is we're going to dip this bottom fold of the accordion into the water to make it wet. Then you're going to lift it up out of the water. So right now I only have the very bottom fold wet. Now I'm going to go ahead and I'm going to lower this towards the water, and I want you to really watch what happens as it gets very close to the water. Do you see that? It jumps. Let me show you again. It pulls itself towards the water. Huh? It's like it's reaching towards it. Can't wait to get there, right? So why did that happen? What's the science? Well, the water molecules that are on this strip of paper and the water molecules that are in the cup are attracted to each other. So we call that cohesion. The water molecules are also attracted to the solid paper molecules, which we call adhesion. And these forces cause the strip of paper to reach towards the water when it gets close enough. All right, get ready. You are gonna love this. Activity 7 deals with capillary action. So what you're gonna need for this activity is a plate, a piece of paper towel, a piece of foil, and your 9 sugar cubes. Go ahead and gather all those materials. Come on back when you're ready. All right, we are gonna start by making a tower with 3 sugar cubes on the plate. So it's going to be tower number 1. Next step, we're going to make tower number 2. But tower number 2 is going to be a little bit different. It's going to be 1 sugar cube, then the piece of foil, and then 2 more sugar cubes on top of the foil. Tower number 2. And tower number 3 is going to be 1 sugar cube, piece of paper towel, and then the 2 sugar cubes on top. So tower 1, tower 2, tower 3. We are now going to be adding some water to the plate. I have the water colored blue, so that way it's easier to see what's happening. So I'm going to think when we pour this water on here, we're not going to be pouring it directly onto the towers or the sugar cubes. We're going to be pouring it here, and then we're going to just observe and see what happens. So what do you think is going to happen? I want you to go ahead and pause the video and make your hypothesis. All right, we are ready to test our hypothesis. So go ahead and pour your water on the plate and observe what's happening. I see that the blue water is traveling pretty quickly. It's almost at the top of the second sugar cube here. Here it's coming through the paper towel. It's already at the second, but not as fast as this one. On this one, I don't yet see any blue water on the second cube in the tower. Oh. This tower crashed first, right? Already at the 3rd sugar cube? Okay, so let's talk about what just happened there. Let's think back to tower number 1. It was the 3 sugar cubes by themselves. We noticed that that blue water traveled up through all 3 of those sugar cubes, and it did that by something called capillary action. So in capillary action, liquids can move upward against gravity through small openings or through porous materials. So the sugar cube is a porous material and it traveled upward pretty quickly, right? Now think back to that second tower where we had the piece of foil in between. Did that blue water ever make it through the foil to get to the second sugar cube? No, it didn't. That aluminum foil stopped the water from passing through, so only that first cube was colored. And then the 3rd tower, what happened there? Well, we noticed that the water was able to make its way through the paper towel and get to that second sugar cube. So again, capillary action, it was traveling through the paper towel, right? A porous material made from trees. Those large pores allowed the water to travel up through it by capillary action, and then it was able to color the other sugar cubes in that tower. So let's think about this. We just saw all three of the properties that we've been talking about with water tonight: adhesion, cohesion, and capillary action. So think back to tower number 1, where it traveled pretty quickly, right? We know that the sugar cubes and the water molecules were attracted to one another, and this is called adhesion. We also know that the water molecules were sticking together, which is called cohesion, and then capillary action was where the water or the liquid was traveling upward against gravity through those materials. Pretty cool, huh? Here's our water highway after 1 hour. So what's the science here? We had an empty cup in the middle, and look at it now. Well, the blue water and the yellow water moved up the paper towels and into the empty cup, and they eventually started filling the middle cup, causing the water in there to turn green, because we know that yellow and blue combine to make green. This is due to capillary action. The water in each cup travels up the porous paper towel against gravity and into the middle cup. The water molecules are attracted to the molecules in the paper towel, which we call adhesion, and they are also attracted to each other, which is cohesion. Okay, we have one last activity in our water rules lesson, and this one's called blooming flowers. So for this one, you are going to need to cut out and decorate one of your 2 flowers. So why don't you go ahead and do that now? Come back when you're ready. Now that you have your flower decorated and cut out, you need a bowl of water that is 3/4 full. We're going to take our petals and we're going to fold them inward towards the center of the flower. Okay, and once we do that, we're going to go ahead and place the flower in the bowl of water and observe. Do you see what I see? The water molecules are attracted to the paper, and as the water travels through the paper via capillary action, it caused the paper petals to unfold, and it looked like this flower just bloomed before our eyes. I hope you had as much fun as I had today discovering all of those awesome properties of water. I'm Jellyfish Jill, and I will see you back next week for Discovering Density.